Hey yo, this is question 10 on the M25 AAHL Paper 1 Time Zone A. This is a very straightforward question, and I would expect every single well-prepared student to get a perfect 18 marks on this question. So, let's get started with part A. In part A, you are asked to complete the square for f. So recall that f is equal to this guy. And you're asked to complete the square. We can say that the value of a is equal to 5. The value of h is gonna be the same as the line of symmetry of the function f. So the line of symmetry can be found by taking the average of the two roots. So the two roots here are -1 and -3. So when we take the average, we would get -2. Thus, h is equal to -2. Using the fact that x equals to -1 is a root, we can write that f of -1 is equal to 0. From there, we can find the value of k readily. Putting it all together, f of x is equal to 5 times x plus 2 squared minus 5. Part A is done. In part B, you are asked to sketch the graph of y equals to f of x. On the sketch, you must indicate the intercepts as well as the coordinates of the vertex. The coordinates of the vertex can be readily determined from the vertex form that they asked us to do earlier. So it's going to be -2 and -5. Recall that the coordinates of the vertex is h, k. The intersections with the axis. Now consider the x-axis. We already know that the roots of this function are -1 and -3. Finding the intersection with the y-axis, you have to find f of 0, which is equal to 15. Putting it all together, you will have the following sketch. Five, 10, 15, -5, -3, and -2. The vertex is at -2, -5. The roots are at -3 and -1. The y-intercept is at 15. So because of symmetry, it will also have to pass this point over there. So let's join the points. Joining the points will give us this smooth curve. Voila! That, my friend, is 8 marks for parts A and B. Very straightforward. Part C. We are now asked to solve the inequality. F of x is less than or equal to 40. So, let's do this. I will divide both sides of the equation by 5 because we are dividing both sides by a positive constant. The sign does not change. Now I'm going to expand the brackets. The reason being that we need the right-hand side to be 0. So I'm going to move the 8 from the right-hand side to the left-hand side. Factorizing the left-hand side will give us x plus 5, x minus 1. We know that the two roots of this quadratic expression is -5 and 1. And if we sketch this function out, we would get something like this. You can also use a sign diagram. This method is identical to the sign diagram. We're interested in the interval where the function is negative. In other words, this area over here. Therefore, we conclude that x is between -5 and 1. In the second part of question 10, you were given a function g. G of x is equal to ln of x. In part D1, you're asked to write down an expression for f of g of x. So f of g of x is equal to 5 times ln of x plus 1, ln of x plus 3. Wherever you see x, you now replace it with g of x. Replace x with g of x. In part 2, you're now asked to solve the inequality f of g of x is less than or equal to 40. Looking back at the previous part, we can see that this inequality is true whenever ln of x is between -5 and 1. Once again, you replace x with g of x, and in this case, g of x is equal to ln of x. And to solve for x, we just got to raise both sides to the power e. And that is your final answer. In part E, you're now asked to find a domain of g of f. Now, recall that the domain of g is x greater than 0. You can think of the composite function as a function machine. You have x going into the machine, that's called f. This guy spits out f of x. This f of x then enters another machine, g, and it will spit out g of f of x. Because g can only take positive values, the domain of g of f of x is basically the values of x where f of x is positive. F of x is positive when x is less than -3 or x is greater than 1. How do we know this? We can go back to our sketch in part B. F is indeed positive to the left of -3 or to the right of -1. And that is the end of question 10. This is question 11 of the AAHL Paper 1, May 25, Time Zone A. In parts A and B, you're asked to find the acute angle between two planes, and you're asked to find the equation of another plane, given that it is perpendicular to the first two planes, pi1 and pi2, and it also passes through the point of intersection R, 5, -5, and 5. So let's have a look at part A. You're asked to find the acute, you're asked to show the acute angle between pi1 and pi2 is indeed 60 degrees. So It is always useful to make a diagram, draw a diagram, just like this. You can draw the two planes pi1 and pi2. You can also draw the direction vectors, the normal vectors of the two planes. And using that information, we can then deduce the value of theta. So, if we want to find the angle theta, we can construct a diagram that is like this. So this is your theta. We know that n1 by definition is perpendicular to pi1. We know that n2 by definition is perpendicular to n2 by definition is perpendicular to pi2. When we find the dot product of two vectors, we're finding the angle between them. So if n1 looks like this and n2 looks like that, what we're finding is this angle. So we could be finding this angle. And then from there, we can just take 180 minus alpha to get theta. So let's do the math. We know that n1 dot n2 is equal to the magnitude of n1 times the magnitude of n2 times cos of alpha. Cos of alpha is therefore n1 dot n2 divided by the product of the magnitudes. N1 is a normal vector of pi1, and we can read off this normal vector. It is 1, 2, and 1. Likewise, the n2 is equal to 1, -1, and -2. The magnitude of n1 is the square root of 1 squared plus 2 squared plus 1 squared. The magnitude of n2 can be calculated in a similar way. Performing the dot product, you take the product of each coordinate and you add them together. So in this case, it's 1 times 1 plus 2 times -1 plus 1 times -2 divided by root 6 times root 6. So it's 1 minus 2 divided by 6. So it's going to be -1 by 2. Cos of alpha is -1 by 2. Thus, alpha is going to be arc cos of -1 by 2, or 120 degrees. But if we go back to the diagram, we can see that theta and alpha will add up to 180. Therefore, theta is 180 minus alpha, or 180 minus 120, or 60 degrees. End of part A. In part B, you're asked to find the equation of another plane that is perpendicular to pi1 and pi2. The moment you hear the phrase perpendicular to something, in this case, perpendicular to two planes, or perpendicular to two lines, this is the code word for finding the normal. So the normal vector of this plane, let's call it n3, is gonna be n1 cross n2. n1, that is 1, 2, and 1, and 2, that is 1, -1, and -2. Finding the cross product, you can use the formula in the formula booklet, or you can just write it out. So cover the first row, you will get 2 times -2 minus 1 times -1. Covering the second row, you will get 1 times -2 minus 1 times 1. Because it is a second row, you must add a minus in front of it. Cover the third row, you will get 1 times -1 minus 2 times 1. And this will give you -4 plus 1, negative, -2 minus 1, and -1 minus 2, or -3, 3, and -3. We don't have to use this normal. We can multiply this by a scalar multiple, by a scalar, to obtain a nicer looking normal factor. So nothing stopping us from multiplying this factor by 1 by 3. So you can choose your normal to be -1, 1, and -1. If you went with -3, 3, and -3, that is perfectly correct. Now that we know the normal factor of this plane, we can write the equation of the plane. So the equation of pi 3 is gonna be -1 times x plus 1 times y minus 1 times z is equal to a constant. We know that the plane passes through the points r, 5, -5, and 5. Therefore, we're just gonna plug this point into our equation, and we will get d is equal to -15. Thus, -x plus y minus z is equal to -15. All equivalent answers will be accepted. In other words, if you do -3x plus 3y minus 3z is equal to -45, or if you do x minus y plus z is equal to 15, you will still get full marks. Part C of question 11 is very interesting, as it is a plot twist from IB. It has absolutely nothing to do with parts A and B. You might as well ignore the diagram and just pick out the triangle RQP to finish the question. In part C1, you're asked to show that sine of 75 degrees is √2 plus √6 divided by 4. This is, I would say, bookwork. 75, we can break it down into 30 and 45. The compound angle formula for sine says that sine of A plus B is equal to sine A cos B plus sine B cos A. In this case, A is 30 degrees and B is 45 degrees. So I'm just going to do that real quick. Sine of 30 degrees, that is 1 by 2. Cos of 45 degrees, that's √2 over 2. Sine of 45 degrees, that's √2 over 2. Cos of 30 degrees, that is √3 over 2. Doing basic math, that will give you √2 by 4 plus √6 by 4. In other words, the given answer. Easy, 3 marks. The last part of the question is on finding the length of QR. QR is over here. So we know that to find the length of QR, we have to use the sine rule. So RQ over sine of 45 degrees is equal to 5 divided by sine of RQP. RQP is the missing angle, right? So it is going to be 180 degrees minus 60 degrees minus 45, and that will give you 75. RQ, therefore, is equal to 5 times sine of 45 degrees divided by sine of 75 degrees. And from here onwards, it is nothing more than a ton of search manipulation. It also seems to be a theme that the IB loves every single year. They will always give you a question that will evaluate your ability to confidently handle certs or radicals for the North American peeps. Okay, so upstairs we have 5 root 2. That 2 can be shoved downstairs. Root 2 plus root 6 will stay downstairs. That 4 can be shoved upstairs. Cancel, cancel. You are now down to 10 root 2 divided by this guy. The final answer is in the form p times root q minus 1, so we must rationalize the denominator. The conjugate of this is root 6 minus root 2, so we're going to multiply the numerator and denominator by the same constant. So we have 10 root 2 times root 6 minus root 2. Downstairs, we have 6 minus 2. We can factor root 2 from here. That will leave us with root 3 minus 1. That's what we're looking for. That's what we're looking for. Divided by 4, and you will get 5 times root 3 minus 1. In other words, P is equal to 5, and Q is equal to 3. And that is the end of question 11. A very good plot twist from the IB.